Hello, good morning student. Today we are going to discuss about protection and deprotection. Yesterday we have discussed all the syllabus of M.Sc. second year, third semester, course number CBOP3. Yesterday I already told about that CBOP3 means choice based optional paper 3. Our previous year word paper is a CHO 353. The name of our course is protection, deprotection. A part protection, deprotection, chiron approach and carbohydrates. 4 credit, 48 lectures and 24 tutorials. So there are two sections. Section number 1 includes, or section number 1 deals with the protection, deprotection and carbohydrates. That is 24 lecture required to complete this course. Section 2 deals with carbohydrate chemistry. It requires 24 lectures to complete this topic, carbohydrates. So today I am going to teach you the protection and deprotection. Number 1 point, protection and deprotection. Protection and deprotection. Protection and deprotection. Yesterday we have seen with the help of one example why protection is necessary, why it is important for the research point of view or to achieve the desired product, because our organic compound containing as a many functional groups, and while synthesizing as a new compound which is useful for medicinal purpose as well as for other benefit of it, to prepare that desired product, we must, and while synthesizing our drug or while synthesizing as a important organic compound, there are many steps required to achieve that desired product, and while achieving that desired product, some of the functional groups are reactive than the other one, and therefore the reaction should take place at one center, and the reaction does not affect to the another center, and that is the main purpose of protecting. That protecting means it is a temporary modification of one functional group, and under the mild condition. Yesterday we already learned that ideal protecting group. What are the criteria for ideal protecting group? Number 1, the protecting group should be introduced under the mild condition. Number 2, the reaction is the protecting group should be stable at reaction condition, necessary carry out the transformation. And number 3, Number 3 should be removed under mild condition. So these are 3 important criteria which tells or which describe the ideality of the protecting group. So yesterday we have seen one example, that is a acetoacetic ester or beta keto ester or ethyl acetoacetate. When it is treated with Grignard's reagent, it gives the various product, mixture of the product. When the mixture of products are there, we require only as a one product. So this one product, how to achieve that desired product, for that purpose we must protect one of the group, means mask. Nowadays masking is nothing but as a protecting that group at by using as a suitable reagent and necessary reaction carried out, and during that reaction that protecting group should be stable. It does not get affected by the reagent we are using for oxidizing purpose or reducing purpose or converting one functional group into as another functional group. So during that transformation, that protecting group should not get affected, and whenever it required, that original functional group should be generated after completing the necessary transformation. After getting as a desired product, we must remove that protecting group under mild condition. So that is the protection means what? The group modifying the functional group is known as a protecting group, and that protecting group, and there are the various functional group. Let me tell you about the functional groups are there. Functional group means what? The atom or group of atom that determine the physical as well as chemical property of the organic particular family of the organic molecule is called as a functional group. Or in a simplified way, or in a simple definition of functional group is a site of reaction. Site of reaction means what? When we are adding the reagent, the changes occur at a particular region or particular specific site, only that part is changing. So that is called as a functional group. So let us see first the functional group like as a ketone group. Ketone groups are present in the various, like as a ketone, aldehyde also containing as a carbonyl group, then acid, then ester, carboxylic group, and then alcohol and amines group. So these are so many functional groups are present in the organic compound. So let us begin with, according to our syllabus, the first functional group we are going to study, that is a hydroxyl group. First one is a hydroxyl group. First point we are going to see here, hydroxyl group. Hydroxyl group, as we know that it is a OH, and that hydroxyl group, OH group, it is a functional group. And as we know that this hydroxyl group, so alkyl ether, we can call it as a alkyl ether. Alkyl ether. Alkyl ether means that alcoholic group, means this OH can be changed into as alkyl ether, means here it is changes into OR, means here hydrogen atom get replaced by R group. and that is nothing but as a protection of that alcohol. And as we know that this hydroxyl group, OH group, is present in a primary, secondary, tertiary, as well as in a phenolic OH. So this is the nature of that OHR present hydroxyl group. Now first reagent, how will you replace that hydrogen by R group? So protection as a ether. First one, suppose as a, let us see here, protection as ether. Protection as ether means hydrogen atom get replaced by the alkyl group. So that is the first one, protection as a ether. Why protection as a ether? Because if you look at here, ether are stable at basic condition as well as in most of the oxidizing reagent it is a very much stable, and that's why it is act as a protecting group. One of the there are the various protecting group we are going to learn in this under this heading. So first one is a protection as a ether. So first one, let us see here. First, suppose we have a remember 3 point you must remember. So first one is a should be stable, should be introduced under the mild condition. What is the first? Should be introduced under mild or milder condition. Second one, should be stable at reaction condition or reaction condition necessary carry out transformation. And third main point you remember, should be removed under mild condition. So these are the 3 criteria for the ideal protecting group. First one we are talking about the alcohol. As we know that everybody know that ROH, this is a general formula of alcohol. If you take as a pH, that becomes as a phenol. So here ROH, then what we are going to use here, plus that is alkyl chloride RCl in presence of pyridine. What do you get? This hydrogen atom get replaced by ROR, you can call it as R dash, and there is a again further step you have to should be removed under mild condition. Just if you use here mild acidic condition, you are going to get the final product maybe as a alcohol, should be a alcohol. So this is here protection introduce at basic condition, introduce at basic condition, and this is removed under mild acidic condition. So that are the 2 steps must be remembered while talking about the protection and deprotection. In the first step, we have introduced the protecting group by using as a suitable reagent. The suitable reagent is alkyl halide here, and in the second case, deprotection of that means we are getting as our original compound, that is alcohol, by using as a suitable reagent. We got our alcohol back here. This is alkyl chloride just treated with the acidic condition, and as we know that acid a mild acidic condition, it can cleave the bond between carbon and oxygen, that is a heteroatom, very easily we are getting as a final product, maybe as a alcohol. Now let us look at as a mechanism of protection here. So here what is happening here are OH. In this case oxygen atom are more nucleophilic in nature, and then base is a here used as a pyridine, and as we know that pyridine is a basic in nature, we know that the structure of pyridine is this one. This is a structure of pyridine which has a lone pair on it, and this is a aromatic compound that lone pair are not involved in the delocalization, it is free for donation, and that's why pyridine act as a weak base here. So that pyridine, what the pyridine will do here, pyridine can pick up the proton from here, negative charge present on that oxygen atom, you are going to get here RO minus, and then further you can treat this with RCl, that is R dash Cl, which is a alkyl chloride. What is alkyl chloride? The carbon atom in this case is a electrophilic in nature, this is a nucleophilic. Substitution reaction takes place here. This negative charge attacking on that oxygen atom, and this chlorine atom is a living group, depart from this, and whatever H here, there is a evolution of SCl, and we are going to get here the product RO R dash, which is a ether. That alcoholic group get protected here. So this is the simplest mechanism of this protection. Now let us look at the mechanism of deprotection. Mechanism of the deprotection. In this case, let us see the starting material. Here is a ether, RO R dash you can call it, and then it is treated with as acid. What is going to happen? The lone pair which is present on oxygen atom will attack on that proton H plus, and you are going to get RO, then R dash, here H. The oxygen normally has a 2 bond. Look at here, there are the 3 bonds are there, and therefore positive charge comes on that oxygen atom, and then during the work of that water molecule is going to attack on that R group, and that positive charge get neutralized. The resulting compound or the product form is a OH, is a alcohol, and so this is a mechanism, or we can call it as a deprotection of this protection, and the deprotection how it is occur as an ether. Just now we have seen. Now let us look at the second example of protection as an ether, because we are talking about the protection as a ether. So here second example of protection as an ether, the second is taken here, is second one is the, as we know that this one PH CH2 Cl, which is known as benzyl chloride, or in short we can write this one BnCl. The name of this reagent is called as a benzyl chloride. This one is called as a benzyl chloride, means protection of benzyl chloride we can call it as here. So benzyl chloride, this is one of the, what we can call it as a one of the best protecting group as an ether of the alcohol. This is a second reagent, suitable reagent, which can protect the alcoholic group by using as a benzyl chloride. So now, according to our general guideline, what do you see here? First one should be introduced under mild condition. So this group is introduced at basic condition. This benzyl group is introduced at basic condition. Benzyl group is introduced. Benzyl group is introduced under basic condition. And now second one, when the reaction carried out, the protecting group must be stable during that reaction, during that transformation, and lastly, at the end of the reaction, we should regenerate, or we can regenerate our original alcohol as it is, and therefore should be removed under mild condition. So removed by hydrogenolysis, and this compound is removed by hydrogenolysis. Removed by hydrogenolysis. What do you mean by the hydrogenolysis? Which is the reagent used here? For hydrogenolysis, which is the reagent, that information we will learn shortly. Let us first see the general reaction of this protection. Let us see here, for example, we have a starting compound is ROH, that will be treated with this one pH CH2 Cl. Under basic condition, you can use as a pyridine here. Pyridine is acting as a base here to remove the acidic proton which is attached to that oxygen atom. Very easily get removed by using as a pyridine, so that we are going to get here R, then O, then CH2, pH, or this, in short we can write this ROBN. BN means benzyl group, and therefore this is called as a protected as an ether, because here is a oxygen atom, carbon atom, and this side also has a carbon atom, and therefore it is protection as an ether. That is a very good reagent used for the, and it is an important one because it is a frequent use while carrying out the transformation of one functional group into as another functional group. So that now this is what we did here, we are introducing the benzyl group here under the mild basic condition. Now the second step is a removal of this group just by hydrogenolysis, means H2 palladium in presence of charcoal. This is known as a hydrogenolysis. What? H2 in presence of hydrogenolysis. What is going to happen here? The product we are going to get here ROH, and the side product mainly obtained here is a CS3 and pH. This is nothing but as a toluene we are getting here, right? So this is known as a hydrolysis. Let us talk about something about the hydrogenolysis. Hydrogenolysis means what? So which group it is cleaved, that we are going to see here. In this case, hydrogenolysis means it is a very good reagent. It is selective, it is a stereoselective, means it is selectively breaking the heteroatom, particularly oxygen carbon bond and carbon nitrogen bond. It does not affect the other bonds in this, only as a benzylic. For example, suppose you have a hydrogenolysis. We are talking about the hydrogenolysis, how it takes place. Let us see here. Suppose as a hydrogenolysis, suppose we have a starting compound is let us see here, this one is a benzene and then CH2, then OR. General I am talking about. This is this CH2 or this bond is called as a benzylic carbon oxygen bond. If suppose as a OH is directly suppose as a methoxy group are there, in the next example we are going to look, but this bond carbon and oxygen bond, this is going to cleave, this bond is not going to get affect, only the benzylic carbon oxygen bond, and this bond is going to break only. It does not break the bond between this oxygen and this carbon atom. Only this carbon and this oxygen, means benzylic CO bond, get cleaved by this process, this CH2, then palladium in presence of chalcohol. This is known as a hydrogenolysis process, and the product we are going to get here, this one is a toluene CS3 and plus HOR. This is a alcohol. This is the product we are going to get in this case. Remember this one. Suppose in another way, suppose we have a instead of this, suppose you have another example. Let us see here. Then NR2, right? This is the bond between this carbon and nitrogen. This bond is going to cleave, going to break here, and this is nothing but as a benzylic CN bond. This is going to cleave, and we are going to get the formation of H2, then palladium in presence of chalcohol. This process is known as a hydrogenolysis, and the product formed will be this is a side product, actually is a toluene. This is known as a toluene, and this is a alcohol. And here we are going to get as a toluene again, toluene which is a side product, and then R2NH, that is a amine, secondary amine we are going to get here. So this is known as a hydrogenolysis. Now we are going to see the mechanism of protection as well as mechanism of the deprotection, and it's very simple. So let us see here mechanism of protection and mechanism of deprotection, how it takes place. If you and let me tell you, this subject or every organic subject is a very easy. If you pay the attention from the beginning, it's very simple. You must know the basic principle behind this, and let us see here mechanism of protection here. Mechanism of protection. Now here starting compound we know that ROH, right? This is alcohol. Then in a basic condition, pyridine we are using. Pyridine, the function of pyridine base will abstract this proton and negative charge leaving behind. So oxygen acquires negative charge RO minus and then plus, treated with Cl. I am writing for sake of convenience this CH2, then pH, or we can write this one Cl and Benzyl like this. Or let us see here, this CH2 is going to attack on this CH2 benzylic carbon, and this get cleaved, and we are going to get the product here. The product we are going to get RO, then CH2 pH, or we can just write here in short RO, then Benzyl, right? So in this way, and it is a stable, the stable at reaction condition, stable at reaction condition, or in a neutral condition, or what we can call it as a stable in a mild or alkaline condition, or most of the oxidizing reagents. So these are the things you have to remember while showing as a mechanism. Now let us see the mechanism of deprotection. Mechanism of deprotection, how the mechanism of deprotection takes place, let us see here. Here we have this one RO, let me write here again, CH2 pH means phenyl group pH in short, then that will be treated with H2 in presence of palladium charcoal. There is no specific mechanism, but let me tell you how will be the mechanism. May appear here hydrogen atom and hydrogen atom under the palladium charcoal, that is the supporting. So this bond may cleaved in this way, and it can form the one hydrogen goes with oxygen and one hydrogen goes with that CH2 group, so that we are going to get ROH and then CS3, then pH, or this we can write in this way also, CS3, that is a toluene, right? And this is a alcohol. This is a mechanism of deprotection. So this is a second reagent. We have seen protection as an ether, so very simple. Now let us look at the third one, which is third example is a, let us see here, third one. Third example will be this one. This is called as a PMB. So that is given in the universal syllabus, PMB. So what is the full form of PMB? The full form of PMB is nothing but as a para-methoxy benzyl chloride. That is a name of or full form of that PMB, and the structure of this PMB will be this one. We can write MEO, then benzene ring here, and CH2Cl. Everything is the same what we have seen in case of the benzyl chloride. Same thing, it is a protecting. Instead of that benzyl chloride, we can use as a para-methoxy benzyl. Everything is the same. For example, suppose we have a starting compound is this one, alcohol, as we know that ROH, right? And that ROH further treated with PMB means what? This Cl, CH2, then you can write in this manner, in presence of base normally employed as a pyridine which is readily available, and therefore you are going to get here RO, then CH2, then this one OMe, and this group we can write in short ROPMB. So ROPMB you can write in this way, and now this will be deprotected by using what we can use as a H2 in presence of palladium charcoal. This reagent or this process is known as a hydrogenolysis. Hydrogenolysis. So hydrogenolysis, it will deprotection takes place, and we are going to get our original compound is a ROH alcohol here, and side product may be as a this one. Side product may be as a this one CS3 para-toluene para-methoxytoluene, or we can call it as a para-methyl anisole, you can call it any way you can call it, but prefer to call it as a para-methoxytoluene. So this is again as a alcohol, and this one is nothing but as a, what is this? This is a para-methoxytoluene, that is the name of this compound. And if you look at here the introduction of this PMB in a basic condition, and the reaction is carried out, and that PMB does not get affected by this reagent, and now the deprotection is carried out, means removal of, or it is removed by hydrogenolysis, and the mechanism of this one is similar. Mechanism of protection is similar to the benzyl chloride. What is changes here? Only there is a OMe is introduced here, and rest of the thing remains as it is. But one question may arise in your mind is that, look at here, while in the hydrogenolysis means from here, suppose as a RO, then let me write here CH2, then this is a group OMe. Now the hydrogenolysis, the hydrogen atom and this hydrogen atom, this bond is going to cleave here. Why not this bond, carbon and this is a benzylic, this is not the, this is called as a bond which is directly attached to the carbon-carbon double bond, or here maybe as a carbon and oxygen atom, it does not get broken there, only as a benzylic. Benzylic means this carbon atom sp3, and this bond is going to cleave, and therefore it get the deprotection, means we are getting as a original alcohol and the side product. Don't think about the side product, you must focus only with the main products are there. So I think these are the three, and there are many protecting group that we are going to in the next lecture. Let us stop today here. Have a nice day. Thank you.